Okay. So in case we are, if I by the flow, the switchgear size is suppose that the 1000 ampere, or I choose the CT is the 1000/1, yeah, 1000/5 ampere.
Okay.
Okay. So if I go for the CT sizes, suppose there's a 2000 meter, 2000 ampere. It
Yeah.
may be in the future that they will add the one more feeder of 1000 ampere. So we can add this. This is not impacting, or it will impact.
No, it should not do that. It's like you have to go for the next tapping. Yes. So we are having a tappings in the city. Like if you connect with these two ends, it will act as a 2000 amp or 1 amp city. If you connect to these two map points, it's like 1000 bar 1 amp city. So at present, if your load is 1000 bar 1, you are connecting to these nodes. And if you are if you suppose if you add some load on this, then you are connecting here. So this how you have to do. You should not add the load on
It's
this.
a dual core city.
Sorry.
Dual core city. It's a dual core city, or the single core, but there
Single
is the
core with
option
multiple tappings.
variable, multiple tapping.
Single core with two tappings.
Okay. And what about the multi-core?
Multi-core discussed, right? We are having multi-core generally for a core saturation, because the metering CT should saturate at one point, the protection CT should saturate at one point, and the protection class CT, PS class CT should having some other way of saturation point. So these three cannot be attained in single core. So definitely this should have a separate core, this should have separate core, and this should have separate core. So 3 cores of CT, one for metering, one for protection, and one for unit PS class. And inside this, you can have the multiple tappings like this. This will give one reading, this two will give one reading, this two will give one reading. 800, 600, 400 bar, 1 dash, 1 dash, 1 amp.
So it is possible we can select the, if we are selecting the 3-core CT, but the 1 core, 2 core, and 3 cores, the capacity, the ampere rating may different.
Ampere, why it is different? Same, right? The same CT you are using, right? For in that feeder, the ampere rating is same only, right?
But we are using the different core. Now, suppose that you told me, na, one we are using for the metering, one for the protections. So if we have required for the metering is the 1000 ampere, but protection we have required only the 10 ampere, 15 ampere, maybe the 20 ampere.
I see. No. I think you are a bit confused. See, my rated current is 400 amps, right? If in the metering, if this is the metering core, what it will do is, if 400 amps is flowing, it will give 1 amp. This is the primary working of this. And the protection core, it will not give any, it is also giving 1 amp to here. And the PS class core is also giving 1 ampere. This is generally giving. Now, if suppose a 800 amps is flowing, 800 in the sense a fault occurred. So now this also giving 2 amps, this also giving 2 amps, and this is also giving a 2 amps. But to which application this went? This is went for the metering. So no operation here. This is went for the unit protection, whether it's checking, whether it is in this zone of protection or not. So here also no operation. But it is went for the overcurrent relay. So overcurrent relay, in that relay, I built an algorithm. In that I am saying that if the secondary side of the current is greater than 1 amp, please trip. So it's seeing the 2 amps. So this will give a command to the breaker to trip. All the CTs are seeing the same current only.
But output may different.
Output also same. It is giving 1 amp on all, but going to different applications. One is going for the relay, one is going for the meter, other one is going to the some other relay. So
Okay.
to avoid the maloperations, to make this as a specific application, we have to design this as the core in a separate way. This should be in separate way. This should be in separate way. The design of the core with respect to the saturation is different. Remaining all same.
Okay. So have you picture of this kind of the relay, 3-core relay?
3-core CT. Cross section of the 3-core CTs you can see in the night. Wait a minute.
Yeah, in three phase, if in R and Y is 10 BA cities are there, 10 BA burden cities are there, but I'm present. I don't have 10 BA cities, but I have 150 BA city. At that condition, can I put it that city in that series?
Sorry, please come again.
Yeah, I have three cities RYB. R and Y is I have same burden 10 BA, but due to some issues, one city will be failure. I have to replace that new city, but I have the new city with 50 BA city. Can I put it in that
Button, huh?
burden?
But the rating all are same, huh?
All are same. Rest of all are same. Only burden only
Yes.
more.
So just check that whether the button. So if you place that, what is the actual button? What is the rated button? If that button is higher or lower?
Higher.
How much higher? Before it is 10 VA, now it is 50 VA, na?
50 VA. Yes.
Yes. Now, if you place this button, if you place this CT there, then what will happen is you have to calculate the what is the actual ISF there. Suppose for the metering, you are talking about metering.
Protection.
Yeah, protection. For protection. For protection,
Yes, for protection.
For protection, obviously it won't be a big issue. You can keep, because here, if you place the big button also, the ALF will be high only. So if a ALF is high, the required, obviously it is required ALF is low, which is already satisfied with the low button. So it's not a big thing for you. But if you're doing the same with the metering, you have to check with the relays which are connected on the downstream.
But anyhow, I putting that higher side of burden only, no? Then that relay side, what earlier connected, that should be lower than 10 BA. So I think 50 BA will be not an issue for metering purpose also. No.
See,
okay.
The relay you are saying that 50 VA is a rated button. 50 VA you are asking the rated button. For that rated button, the ISF is designed, but you are giving only few button, or only 1 VA button. Then ISF will be very, very high. So the CT will not enter into saturation. So the secondary current will flow, which this secondary current may damage the equipment, the secondary side, the relays or MFM or whatever you are connected. So you have to take care. What is the, you have to ensure that overcurrent capability of that instrument should be less than this.
Okay, then for whenever maybe you are going with this metering CT, then we have to burden as well as this IF need to be cross-checked.
Yes,
right?
Yes.
Thank you.
Yeah. I am not able to figure out that core construction view, cross-sectional view. If I find any pictures on this, I will share you. Maybe in the tomorrow's class, I will show you. At present, I am not having that.
Okay.
The cross-sectional view of the CT. But when I had the presentation with the Central Power Research Institute, they shared some articles regarding this. Maybe in that I can find out. If I find, I will share you.
Okay.
Fine.